live from the Veeam studio in Atlanta, Georgia. This is Veeam Whiteboard Fridays, starring your host, the manager of the Inside Engineering team, Mr. Jose Mendoza, alongside the trusty panel of senior engineers, Jason Leyva and Sean Liu. Remember, keep the show interactive with your comments and questions. Now sit back, relax, and enjoy the show.
Enjoy the show, that's right. Welcome everyone once again to episode number 2 of Veeam Whiteboard Fridays, the 5 series that we've got going on. Let me turn the music down here a little bit. It's good to be back. I'm your host, Jose Mendoza. You see the name there on the screen, so hopefully you know who I am by now. But anyway, it's great to have you back. As always, we have Jason and Sean, who we're going to meet here in a few moments. Before that, I just want to remind you real quick, and I'm going to pull it up. These are the beautiful backpack that we're giving away for this series. So please ask questions, keep it interactive, keep it fun, and hopefully you'll get to win one of these very cool backpacks. But don't feel bad if you don't, because we are giving away other prizes as well. We've got a 8 gig USB thumb drive that we're giving away, notepads, and a couple of other things as well. So before we get started, I'm going to turn it over to our panel with Jason and Sean, and they're going to tell us what we've got in store for episode 2 today. So let's go ahead and meet these guys here.
Hey, thanks, Jose. So today we'll be looking at distributed architecture for Veeam Backup and Replication version 6.5. So we're going to show you a actual live demonstration of how to deploy distributed architecture components. Both Sean and I will be going on the whiteboard and kind of drawing out some of how that actually lays out in your infrastructure and how you can deploy those in different manners to get the most efficient usage of your backup infrastructure. So, Sean?
Yeah, so I'm going to go to the whiteboard initially and talk about the actual architecture itself, give you some best practices, some of the different options that you have when you're considering deploying the different components within the Veeam architecture.
Excellent, guys. Appreciate that very much. And what I'm going to do is just throw the agenda up on the screen. And Sean, I think you are going to have to change your battery if you don't mind. I'm getting a lot of feedback on there, so go ahead and do that. But in the meantime, what we'll do is while Sean gets it up there real quick, I'll bring it back here to myself. But look at the agenda. Again, the show is a lot more fun when we keep it interactive. Now, for those that can't make it in today, there will be a recorded version. So if you don't get to stay the entire time, or if you miss it, then you can come back in next week and play it back. So after the show is done, we will upload it to the website. Again, that's veeam.com/whiteboard. If you've registered, you should know where that is already. So I would suggest that you visit if you haven't and register. So what we'll do is we're going to turn it over to Sean over on the whiteboard, and he's going to go ahead and talk to us about today's episode. But again, keep it fun, keep it interactive, and welcome once again. So let's go to Sean on the whiteboard.
So I just want to make note, if everybody just takes notice of this, that I'm just going to use the letter B for the backup server, the letter P for the proxy, and the letter red for the repository. So I'll be using that throughout my whiteboarding session, just to make it a little bit more streamlined here. So just for reference there. So what I have behind me is a basic architecture that I like to use, just simply 3 hosts, vCenter management server, and some storage via SAN. You'll notice that the Veeam backup server here is already deployed. So one of the most popular questions that we get when deploying Veeam inside the environment is, should I go physical or should I go virtual machine route for the Veeam backup server itself? Right? So there's pros and cons to each type. Right? With a physical server, the nice thing about the physical server is that it is outside of the cluster that is protecting. Right? So it's going to give you the best protection possible. Some things to consider there, right? Some of the cons is one, cost, right? You do have to have a dedicated physical server for the Veeam server. And number 2, there's some considerations to take in there, right? With a physical server, to achieve a LAN-free backup, you will have to have access to your SAN fabric, right? The proxy component will. That allows you to leverage the direct SAN access mode and read data directly from the SAN, right? Without having to go across your network. So that requires an HBA or iSCSI connection into your SAN fabric, right? So just some things to consider there for the physical server route. The virtual machine route, right? The nice thing about the virtual machine route is the configuration is very easy. Right? There's nothing for you to actually do. Veeam automatically detects that it is a virtual machine, automatically leverages virtual appliance mode for any volumes within that cluster, and that's it. Right? So it's very straightforward, very easy to install, very easy to deploy, low cost. All it's going to cost you is a Windows license. Right? So that being said, the con of a virtual machine is if you lose your cluster, you've just lost your Veeam backup server. It's not a huge con because you can install Veeam on any Windows-based machine. Very easy, takes roughly 10 or 15 minutes to get it installed. Veeam automatically backs up its configuration data, and Jason can show you that later when he's on the computer, where that configuration data is actually stored by default. You can send it to some location outside of the cluster so that you have your configuration data stored. That way, if you need to deploy Veeam backup and replication again, you can simply just import the configuration and have all of your jobs back in that server. So that's not a huge con for Veeam being on a virtual machine, but just some things to consider there, right? So now, the Veeam backup and replication server itself, there are some basic recommendations that we give just as far as CPU and memory resources allocated for the server. Right? We do recommend that you have 4 cores and 4 gigs of RAM for the Veeam server, whether it be a virtual machine or a physical server. And that's because Veeam does sit on top of a SQL backend, right? SQL Express backend. So it does require some RAM there for SQL. And the high CPU requirement is because Veeam does perform deduplication and compression in line, right? Compression's heavy on CPU, so that's the basis of that particular recommendation. So next, I want to talk about some considerations, right? Before we take a look at the different components and how we can split it out, we got to take into consideration your jobs, right? How do you break out your jobs? There's lots of flexibility within the Veeam backup job itself. Right? You can add virtual machines individually into the job, or you can actually add them by container. I can add an entire host. I can add an entire cluster, an entire data store, a specific folder of VMs. Right? So just some considerations there and some best practices, right, for the jobs. You really don't want to exceed more than 8 terabytes worth of data in a single job, and that's on the high side, right? We really like you to keep it somewhere around 4 terabytes worth of data in a single job. And if you have a large virtual machine that's greater than 2 terabytes in size, you probably want to put that virtual machine into its own job, right? This just ensures that you're going to get timely backups and that you're not going to have any huge backup files, okay? So now that we talked about some of the job considerations, let's talk about some of the considerations when actually splitting the Veeam architecture out, right? It's actually a very good idea to have a mixture with your proxies, right? Because with our distributed architecture, the backup server actually serves as like a central administration console, right? It handles all of the scheduling of the jobs, distribution of job duties to those proxies, and then the proxy component itself does all the heavy lifting, right? It retrieves the VM data, handles the compression, the deduplication, and then it passes the data off to the repository. Repository is simply just a disk-based target where you wish to house your backup files. We are completely storage agnostic on the repository side, so you have a lot of flexibility there. All we're really looking for is a disk-based target to land on. Okay, so before we talk about how to best break apart the architecture of Veeam, let's talk about the data flow, right? How does the data actually flow? And I'll draw the proxy here. We're going to assume this proxy is a physical one. And let's say I also have a virtual machine proxy so I can show you how the data flows in both scenarios. So here in this scenario, I have 2 proxies. One's a physical, one's a virtual proxy. I'm going to assume that the physical proxy does have connectivity into the SAN fabric, right? We want to achieve the best possible performance. So initially, what's going to happen is the backup server is going to communicate to your vCenter server, okay? That's number 1. Number 2, vCenter is going to return the VM list. So now the backup server knows where all of your VMs are located. Now, another consideration here on the backup server itself is how many jobs are you trying to run concurrently, right? I have 2 proxies here. Let's say both my proxies have 4 cores allocated to them. So both proxies are capable of running 2 jobs concurrently, right? Because the rule of thumb for the Veeam proxy is 2 CPUs per job, right? And that's auto-detected by Veeam, and we will set the number of concurrent jobs based on that number. You can increase the number to more than what's recommended. However, you will receive a warning, and it may be a potential bottleneck in your backups. Okay, so the next thing we want to keep in mind, so since both have 4 cores, both can process 2 jobs concurrently, right? So let's say I'm trying to run 4 jobs concurrently. You remember my base recommendation of 4 gigs of RAM, right? That's a base recommendation, okay? So some things to take into consideration is how many jobs am I going to run concurrently. If I'm going to run 4 jobs concurrently, we do recommend that you give the Veeam backup server 512 megs per concurrent job. Okay? The reason for this extra memory is because step 2 there, vCenter is returning us a list of all of your virtual machines, right? Each job has its own list. So that does require additional RAM to hold that list in. Okay, so just keep that in mind. So as you scale out, you will need to scale out the memory as well, right? The RAM requirements there. So now, once we receive that VM list at the backup server is going to select the proxy based on not only availability but efficiency, right? Which proxy can process that particular job the fastest, right? That particular virtual machine. So initially, it's going to hand the job off to the physical server because direct SAN access, top of the list. Okay? So the physical server is going to get the first 2 jobs, right? So what happens next is the physical proxy is going to retrieve the data directly from the SAN, right? You can allocate those, or the visibility into those volumes can be read-only if you wish. However, keep in mind that Veeam does disable auto mount by default so that the Windows machine that we're installed on is not going to try and mount those volumes and format them. Okay? So that's step 3. Right? The physical proxy will retrieve the VM data, and then once it's done with its deduplication compression, hands off the backup file into the repository, which is step 4, where the backup file is finally stored. Okay? So now let's take a look at what happens when my 3rd job runs. Right, so the first 2 jobs are automatically going to go to the physical proxy because it can use direct SAN access mode. But now it's busy processing those first 2 jobs. So job number 3 and job number 4 get handed off to the virtual proxy by the backup server. Okay? So now the virtual proxy is going to leverage virtual appliance mode, essentially using VADP's hot add capabilities. It will leverage the host I/O stack here. Right? So it's going to retrieve data through the host I/O stack, and then once it's finished with its compression deduplication, pass it off to the repository. Okay? So that's how that workflow looks when the proxy is both a physical and a virtual. Okay, so just some things to keep in mind. So now, let's talk about how many proxies, right? That's one of the biggest questions that we get. How many proxies do I need for my environment, right? The answer is it really does depend. You can scale out proxies both vertically and horizontally, right? I can scale out vertically by giving the proxies more cores, right? 2 cores per job. If I gave this proxy 8 cores, now it can process 4 jobs simultaneously instead of 2, right? So you can also scale out horizontally by deploying more proxies, right? And that is completely up to you how you want to deploy it in your environment, and depending on what resources you have available. A couple of rule of thumbs there, just so you get a baseline of what you're going to need, is if you're using the virtual proxy method with 4 vCPUs, roughly 100 VMs with roughly 10 terabytes of space used, 2 jobs at roughly 50 megabits per second, or 50 megabytes per second, that's what you can expect to process with that particular proxy, right? So with a physical proxy, 16 cores, let's say you have direct SAN access and you have 16 cores, so you can run 8 jobs concurrently, assuming a processing rate of roughly 100 megabytes per second, you can expect to process 400 VMs, roughly 40 terabytes worth of data. So you can use that as a baseline. Of course, it is going to vary based on your environment and based on your actual processing speed. But that's just a nice baseline to get started with, so you can determine how many proxies you're actually going to need in your environment. Okay? So now, let's talk about some considerations when we're taking a look at the repository. Right? So now I'm scaling out proxies. Right? I have more than one proxy. I got to really take into consideration what can the repository receive, right? How fast can it receive that data? Just trying to eliminate certain bottlenecks so you can get the best performance possible. Some things to take into consideration with the repository is not only the ingestion rate itself, but the I/O, right? I/O is a big consideration with Veeam. And I'm going to explain why. Because depending on what type of spindles you have for that repository is going to dictate how much I/O it can actually handle. Okay? And another thing that also depends on how much I/O is generated by Veeam is the actual backup mode itself. Okay? So let's take a look at the two different backup modes that we offer within the Veeam solution, and I'll talk a little bit about how much I/O each backup mode generates. Right? So you can use that as a guideline as well into which job mode should I select for my Veeam backup jobs. Okay, so the first and the default backup mode is the traditional incremental style backup mode. Okay, let me illustrate what I mean. So with the traditional incremental style backup mode, the first thing you're going to start off with is a full backup, right? The F is for full backup. Okay. On subsequent runs, we're actually going to leverage change block tracking to help us identify all of the change blocks without having to go and search for them. And we're going to take those change blocks and write them out into standalone incremental files. Okay, so I for incremental. Okay, and we'll do that during the week, right? And on a specific day of the week, which the default settings for Saturday, you can choose any day you like. So let's just say it's Saturday. What Veeam's going to do is we're going to create a synthetic full, right? And what the synthetic full consists of is essentially the incremental blocks for that day. Then we're going to pre-populate the remaining blocks of the synthetic full with this existing chain of incrementals and this full backup. So now this becomes a full, right? The difference between a synthetic full and an active full is the way it's created, right? It looks, feels, smells just like an active full. The only difference is the way it's created. So the advantage of the synthetic full is, on average, only requires roughly a third of the time to create, right? Versus an active full, because we're not pulling all new data. However, there is additional processing that takes place to create the synthetic full. Right? So let's talk about I/O in this specific scenario. With the forward incremental, each time the job runs, for every single block, there is only one I/O. Right? It's just a write. All we're doing is we're writing to the repository. So all this I/O talk that I'm about to reference is strictly at the repository level. Right? So one write to the repository per block. That's it during the first full and the subsequent incrementals. On Saturday, when we create the synthetic full, we're going to have to read data and then write data, right? So there's actually 3 I/O per block when you're talking about synthetic full, right? So that's a significant amount of I/O. If you consider a 7200 RPM SATA drive can give you probably roughly around 100 I/O. Right? We can saturate that pretty quickly. Right? So just some things to keep in mind when you're taking a look at the repository and what backup mode you select. Right? Because this can potentially be your bottleneck in your system, especially if you have more proxies. But don't just keep in mind the backup modes. We at Veeam always stress the recovery aspect of things, right? How quick it is to recover with instant VM recovery, our file level recovery wizards, and our Exchange Explorer. So when you're going to perform those types of recoveries, the performance of the repository is also going to make a difference as well, right? So the big advantage of the forward incremental is that it requires minimal I/O during the week, right? Only one day of the week, which by default, like I said, set for Saturday, does it require more I/O. So your backups are going to go fast, right? It's just one I/O per block. So now let's take a look at the other backup mode that we offer, which is the reverse incremental. Okay, and I'm going to use a different color for reverse incremental. So just like the forward incremental, the first backup is going to be a full, right? Like I said, it's our baseline, our starting point. But on the next run, instead of just taking a standalone file, what we're going to do is we're actually going to push the full forward, right? How we do that is we actually take the change data for that day, those change blocks, and we just take those change blocks and we insert them into the full. Okay? What we're going to do then is we're going to take the blocks that those new blocks replaced, and we're going to create a rollback point with the old blocks. Okay? So the nice thing about the reverse incremental is that that full just keeps moving forward along the chain. Okay? And you'll just have a bunch of rollback points. So big thing is you only have one full ever, right? Everything else is simply rollback points. But at what cost? Okay. Because we're injecting data and then we're writing the data out to rollback points, there's going to be reads, there's going to be writes, right? So 3 IOs per block on the reverse incremental every single day. Okay. So that has to be taken into consideration when you're wanting performance, right? Depends on what you want, performance or space savings. That's how you look at the two different backup modes, right? The reverse incremental, only one full and a bunch of rollback points. So you're really going to get a lot of space savings because I never have to create another full, right? It's a bunch of rollback points. But it does come at the cost of more I/O. So your jobs will take longer. Okay? Now with the forward incremental, it's 1 I/O during the week. So the jobs perform really fast, and only on one day of the week do I do that synthetic full. But you notice I have a synthetic full, right? So, and I still have my previous full. So now I have multiple fulls on disk at any given time. So it does take up more storage space, but it's going to be faster during the week. Okay, so just some things to keep in mind when you're selecting the different job types and when you're choosing a specific repository for your backups, right? Because if you're going to want to use the reverse incremental mode, this is actually recommended only if you're going straight to a disk target and not going to be offloading it for any purpose. Okay, one thing to also keep in mind is if you're going to select a deduplication appliance, a physical deduplication device to house your backups, the recommended approach is going to be forward incremental. Okay? And you do also want to turn compression off. So just some things to keep in mind there. Other than that, let's talk about space, right? How much space am I going to need on my repository? Okay, so the amount of space, of course, is going to depend on what backup mode you actually select. Okay, so you just want to know how often are you creating a full, how many incrementals are you going to have, right? What kind of retention policy do you need? So let's say I have a traditional incremental style backup, and I want to keep 2 weeks worth of data on disk. I'm only backing up once per day. Okay, so your 2 weeks worth of data on disk means that the way Veeam prunes the data, right? I'm only going to have 14 restore points here. If I'm doing once per day, that's going to give me 2 weeks. But I can potentially have up to 3 weeks worth of backups on disk because Veeam, we cannot prune this full backup alone, right? We have to wait till the entire chain expires before we prune the data. Okay? Unlike reverse incremental, where we can prune the data as needed because it's just rollback points, right? It's not dependent on the entire chain. Okay? So that's another distinguishing factor between forward incremental and reverse incremental. Okay? So I can potentially have 3 full backups, right? So I take that number of backups and I figure out what size they need on actual disk, right? Some things to take into consideration there is our overall compression and deduplication ratio. We do like to use 2 to 1. It is a guesstimate. It is on the conservative side because that can range anywhere from 2 to 1, generally up to a 10 to 1, right? So 2 to 1 is conservative of actual used space. So let's say I have a terabyte worth of used space for my virtual machines, right? After compression, after deduplication, I can expect to see a reduction of 50%, right? So what I actually have resided on disk for my full is going to be roughly 500 gigs, right? So okay, at 500 gigabytes apiece. Now, the incrementals that I'm going to have, for 2 weeks, I can potentially have, what's that? 6 incrementals per week, right? And I can potentially have 3 weeks worth. So that could be 18 incrementals. So how do I determine the size of the incrementals? We generally use 5 to 10% for change rate. Of course, if you're heavy on SQL or Exchange usage, those particular virtual machines are going to have a higher daily change rate. But we like to use 10% just as a guesstimate, right? So at 10% for a terabyte's worth of data, I'm going to have 100 gigs worth of change data per day. Reduce it by 50% because of our compression and deduplication. That works out to be 5 gigs of change data per day, right? So now you just do a little bit of math here. 3 times 500 plus 18 times 5, and that'll give you an idea of how much storage space you're going to need for that particular job to meet this retention policy, right? Reverse incremental is a lot more straightforward. Okay, so let's assume these same sizes for reverse incremental. Let's say, remember, I only have 1 full. So that full's only ever going to need 500 gigs, right? But I will have more incrementals or rollback points. Same daily change rate. So I will have now 20 incrementals at 5 gigs apiece, right? So if you do the math, of course, the forward incremental is going to require a lot more storage space than the reverse incremental is. But remember, it does cost more I/O per day. Other than that, that's essentially all I wanted to go over on the whiteboard, just to give you an idea of how to deploy Veeam within your infrastructure. Jason's actually going to show you how to configure a proxy on the computer itself. Okay.
Excellent stuff, Sean. So appreciate that. So hopefully that makes it pretty clear for a lot of you that had some of the questions that Sean was able to answer with the demonstration that he gave for us. So now what we're going to do is, as Sean mentioned, we're going to go ahead and take it over to Jason. Jason's going to do a demo live from the computer itself, and you should be able to see it on screen. We do recommend that you enlarge your screen. If you're watching it right now on the small screen, it's going to be kind of hard to read. So go to a full size. It's probably a good best practice to use to be able to read what's on the screen. So, all right, so we'll go over to Jason.
Thanks, Jose, and thanks, Sean, for that very thorough demonstration of the Veeam backup architecture. So kind of getting into Veeam backup and replication, again, this is version 6.5. We're going to focus primarily on the backup infrastructure tab of Veeam backup here. And what we're going to do is go and add a Windows proxy. So to start with, what we need to do is add a server that we would like to be able to use as a proxy for Veeam. So to do that, let's begin with adding a server, which I'll do up top, or I can also right-click and add a server. Okay, so I actually have a machine in here that I would like to use, and keep in mind all the specifications that Sean mentioned as far as requirements for the proxy and recommendations. And I'm using actually a Windows virtual machine in my case here. So I can give it credentials. Whoops. All right, so it's going to go ahead and detect and see if there's any previously installed components. In my case, I believe there is because it's a lab environment. Components that can be used. Actually, nope, the transport is not there. Let's go ahead and add it. And these are all the services that Veeam will need to use to be able to do, as Sean said, retrieve the data from the infrastructure, ultimately dedupe it and compress it, and then write it off to your repository. So take this just a moment. It's determining all the disks that this proxy can read. And there we go. So now we've added this. Now we need to go make it into an actual Veeam backup proxy, which can be done simply by going to the backup proxies object up here. You can right-click on it, and you add a VMware backup proxy. Okay, and now that VM that I just created, or the machine that I just added, is going to be available in this pull down. And you'll see there's some automatic selections here. So the first one is going to be how can this proxy access data? And as Sean went into, we have direct SAN access for being able to retrieve the data directly through the SAN fabric, the SAN network. The virtual appliance mode is Veeam being a VM, or network mode going actually across your local area network. We'll let Veeam choose automatically. Veeam is going to pick the best one for your infrastructure based on, again, the location of itself being the proxy, its current load, et cetera. That's going to be, Veeam again will make those decisions. Now, as Sean said, for every 2 vCPU or every 2 cores you give the proxy, you're going to essentially get a concurrent task or a concurrent job. So in my case, I have 4 vCPU on this proxy, so I can have 2 concurrent tasks. Now, I can increase this number. You'll see it turns into a warning icon telling me that we only have 4 cores detected. A 6-core configuration is recommended for running 3 parallel concurrent tasks. So we're going to leave it as it is. I don't want to overwhelm or overload this proxy, so we'll leave that there and go to the next step. So one of the things you can establish in Veeam Backup and Replication is traffic throttling based on specific rules, and these rules are actually set globally and automatically identified or leveraged based on the location or the network that the proxy is on. So you can manage, again, these rules globally here for Veeam. You can add them based on the source and target IP range and kind of how much traffic you want to be throttled to and when you want it to occur. For my case, I'll leave this open for now, just kind of knowing that it's there. And go ahead and complete creating my backup proxy. Okay, so the backup proxy is now created. When you go into a backup job, I'll actually go to another Veeam backup server here and look at a job that I have. You're going to see where this is leveraged right on the storage page of a backup job. And as I mentioned, there are automatic selection based on the proxy's current usage, its relationship to the storage, et cetera. So, or you can, of course, identify them yourself. So. That being said, I'm actually going to hand the computer over to Sean. He's going to show us how to create a backup repository inside of Veeam Backup and Replication.
All right, thank you, Jason. So now that we have a proxy, right, we got to take a look at the next component, which is a repository. Now, Veeam does install all 3 components by default, right? So you notice that we had a default backup proxy. We do also have a default backup repository, which the default here, you'll notice, is just the local drive on this particular machine. Okay, that's generally probably not where you want to keep it, right? You want to send it to a specific repository, whether that be some direct attached storage or a Civ share or just a different media server altogether, right? So if I right-click on the repository here and add a backup repository, you can simply come in here and give the repository a name. We'll call it WBF. For Whiteboard Friday. And you'll notice the different options I have for a backup repository. Right? I can select a Windows server, which is just a media server. Maybe I have direct attached storage to it. A Linux machine, right? If you want to use NFS or just some NFS storage mounted to that particular Linux machine. Or you can use a Civ share, right? Just a regular shared folder there. So any of these options are available to you. So let's select Windows Server here, for example. And you'll notice I can drop down and I can select that same proxy that Jason just created to use as a repository, right? And if I click populate here, it'll populate the different disks on that particular proxy you can use. Right? So very easy here. The nice thing about having a proxy and a repository in one, right, is remember how the data flow goes. Once the proxy retrieves the data, right, and generally if you deploy it via a virtual machine or a physical machine with direct SAN connectivity, that retrieval method is LAN-free, right? So if I have a proxy and repository combination where the disks actually reside on the proxy itself, that performance there is going to be really nice, right? Because the proxy doesn't have to send the data anywhere. The storage is already on the proxy itself. Okay, so you do have that option. So now I'll just select this local storage on this particular proxy to use as a repository. You'll notice you can limit the maximum number of concurrent jobs to this repository, right? So if I know that I'm going to have 4 jobs flowing into this particular repository, and remember our I/O, right? The I/O operation is what's important here. So let's say 4 jobs is all I can handle, right? So I can limit how many jobs can go into this particular repository. You can also limit the combined ingestion rate of all the jobs as well. That way you don't overwhelm the repository. Okay. Okay. We'll enable it to be a vPower NFS server because it is a Windows machine. Right. So you'll see that it has been added successfully. So now it'll be available via this menu here. Okay. And that's pretty much it for creating a repository. We can go back to Jason. He's going to talk about how would you deploy Veeam's distributed architecture in a remote repository scenario or a ROBO scenario, right? Remote office, branch office.
Excellent, Sean. Thanks for that. So we're going to take it back to the whiteboard and have Jason just show us a little bit of what Sean's talking about there.
Great. All right. Thanks a lot, Sean. Thanks a lot, Jose. So we talked about distributed architecture. We talked about the different modes. We talked about the proxies and how that stuff kind of flows together. Common scenarios we get asked is, okay, well, I would like to get my backups off-site. I have a central location or a location I'd like to get my backups to. How does that work for Veeam? Another question we have is for remote offices. Perhaps you have a remote office that you'd like to be able to back up machines that are running there, but you'd like to be able to do that centrally. So the Veeam's distributed architecture gives you that capability. So the first scenario I drew up here is essentially 2 sites. We have an Atlanta primary site, and we have one in Columbus, Ohio, that's going to be a secondary site. And the first scenario I'm going to draw is we're assuming that my production machines are running in Atlanta, and I want to back those up to Columbus, or at least want to get the backups there. The first thing I want to make a point of mentioning here, and thing to remember is, while what I'm going to show you is getting the backups off-site, we always recommend that you have a localized copy at your production site as well. For a lot of Veeam's features that require rapid access or quick access to backup, so like powering on a backup for instant Veeam recovery or a Sure Backup Lab, grabbing a file, doing anything like that across a wide area connection naturally is not going to be the quickest way to achieve that, right? So that being said, you can see the components I drew up here. I have an infrastructure, some hosts like Sean drew there in Atlanta, and I have my backup server, and I have my proxy. So the proxy, again, is the engine or the arms of Veeam that is pulling the data from the production storage, or pulling my VMs, and ultimately deduping, compressing, and then backing them up to a repository. Okay, so remember, this repository can be Windows, it could be a CIF share, it could be a Linux server with mounted local storage or NFS share in itself. A couple of best practices to keep in mind here. If I'm going to back up to a remote network share, for an example, like a CIF share, keeping in mind what Sean said as far as the I/O, they're having to read and write data for synthetic fulls and for reversed incrementals. So by having a Windows repository, in this case, what I'm going to be able to do is that Windows server, Veeam will actually deploy our own agent on there, where put a little A for an agent inside there that's going to allow us to offload that rebuilding of synthetic fulls, reversed incremental fulls. That can be done on the side to take the I/O off of the WAN. So not only are you having to worry about whatever storage is attached to it here, this actually your backup storage, not having to worry about that, you're able to take that off like I said, take off the WAN and have that all localized. Now, in the case of a network share, keeping in mind a network share can be accessed directly through here just using a UNC path. We're going to recommend again that you access that through a Windows server for that exact same purpose. So a Windows server with local disk, a Windows server with direct attached disk, or using a Windows server as a proxying server to get to a CIF share, or Linux in the case of NFS. So just keeping that in mind. But remember what I said at the beginning, we still want to have a localized backup for getting the backups back quickly. And this is more of an archiving option for when that retention's already expired here and we need something more long-term. And of course, while we have covered in a previous session, we do have Veeam Backup Cloud Edition to get those backups archived into the cloud as another option, which we won't touch on today, but it is something else that naturally you can do if you're concerned about archiving. Okay. So the other scenario I said was where we do have an infrastructure here as well. So let me go and draw that real quick. So let's say we have production machines running here as well that we need to be able to back up. So as we mentioned earlier, where Veeam has a centralized backup server, perhaps I want to be able to manage all that centrally, but I want to be able to, again, it's all about we don't want to have everything go across the WAN, so I can put a proxy here also. So I have a Veeam proxy. Again, managed centrally and having the proxy server that's going to be able to read from the VMs over here to the proxy and backing them up locally. So again, all the management is still done centrally or another location, but now what we're doing is we're keeping all the data moving, and in fact, this proxy is also going to be what does our restores as well. So it's going to be what's handling the ability to do our virtual machine restores, our file restores, et cetera. So that's really how the distributed architecture works into remote office, branch office, and offsite backups. So that's how that can come into play for you. We'll take a look at this in the next episode, how this plays into replication, because replication is kind of the same scenario where we're not talking about backups. We are still going to have the same architecture coming into play for data moving, offloading some of that data traffic that we have on our WAN connection. So that being said, I'm going to go ahead and take it back to Jose, and he's going to take us from here. So.
Excellent, Jason. Thanks for that. We're actually going to go to Sean real quick, and he's going to show us on the PC what he's talking about. Go ahead, Sean.
Yeah, so just a couple of final points here on the actual computer itself. I just want to show you where the actual proxy and the different repositories come into play when you're creating a backup job, right? So now that you have a bunch of different proxies, you can leave it for automatic selection where Veeam, remember we talked about that algorithm that selects the proxy based on not only its availability, but how efficient it can process that particular virtual machine. But in certain scenarios, like what Jason just described up there with the remote offices and whatnot, you can come in here and set affinities, right? So you can set a group of proxies that Veeam will use for this particular job, a group or just a single proxy that Veeam will use for this particular job. Okay, just wanted to point that out. Here you can also select your different repositories just via a drop-down menu. I can select the one that I just created. Okay. So very straightforward, very easy to go in there and choose your different proxies, your different repositories. It's less, it generally isn't needed on the proxy side because that algorithm is very advanced and will select the proper proxy for you. Okay. So that's essentially just tying the different components together. That's pretty much all I needed here.
Excellent, Sean. Thanks for that. So what we're going to do now is just do some Q&A, and that'll be the second part of this episode where we'll go through and take some of the questions, answer some of the questions that you may have come up with as we go through the show. As always, remember this is episode 2 of a 5-part series. So if you didn't get your questions answered, don't worry about it. We'll continue on. We've got 3 more episodes to go after this. So tune in, go to veeam.com/whiteboard. Make sure you register on there. You'll get notifications to all upcoming episodes from there. So let's.
You have a question, Jason?
Yeah.
I'll let Jason get started here.
Yeah, let's see here. So what are the 3 types of backup repositories that you can have? That's a really good question. So there's 3 that we mentioned. List those out for us, and those will go through the chat window. So, and Matt's going to be monitoring them. So.
First one to respond with the correct answer wins.
So I'll repeat the question again. So the 3 backup repository types that you can have.
Right. Remember the screen when we went through the wizard? There were 3 different options for a backup repository.
Looks like Morgan said Windows, Linux, and CIFS.
Excellent job, Morgan. All right, very good. So Morgan's the winner of that one. Sean, we'll let you have a question now.
Okay, great question. So for the Veeam proxies, how many cores are required per job? I'll repeat the question for the Veeam proxy. How many cores are required per job?
Okay, guys, we got a lot of answers coming in on this one. Let me scroll back to the top.
Very first one gets it.
Let's see.
Like I said in the beginning, I apologize if you have a laggy connection. That can sometimes make the difference between first and second.
This is awesome. I love this interaction. The scroll wheel will not move fast enough. Looks like everyone is saying 2.
I think my question was too easy.
Yeah, you got to make them
so.
harder.
I got to make it
next
more
time, Sean.
difficult. All right.
All right.
I'll work on that.
It looks like Hex Cipher said 2.
That is correct.
Very good.
2
Okay.
cores per job.
So I'm going to go a little more difficult with this this question here.
He always asks the more difficult questions.
Well, so the Veeam backup server there's a minimum amount of RAM and CPU that it needs, generally speaking, but there's also an additional amount of RAM per concurrent job that you want to run in Veeam. What is that amount of RAM that we recommend that you have available for each concurrent job that you want to run? And again, not talking about proxies, we're talking about the Veeam backup server itself, which coordinates those proxies and keeps them talking and all that. So what is that amount of RAM? Sean mentioned early on.
Talked about this in the beginning of the episode. Remember when the backup server itself pulls the VM list, right? There's a VM list per job, right? So how much RAM do we recommend that you have per job for that particular VM list?
Yeah, there's also a lot of good answers coming in here, but I believe T.A. Hood said 2, the first. Is that correct?
No, it's actually not. So it's a great try because you're on the line of the actual minimum requirements. So minimum requirements, as we said earlier, are 4 gigs of RAM, 4 core 4 vCPU. But in addition to just running and typically that's including SQL running locally. But in talking about just coordinating the jobs, grabbing the VM list, as Sean said, there is a set amount of RAM that we would recommend having in addition to those minimum requirements to coordinate all that talking there. So.
Okay, it looks like RP said 512 meg.
Perfect. That is the answer. So, very good. All right. So we have 3 questions today. Is that what we said?
Yep. 3 questions, 3 prizes.
Okay.
For those of you that did win, Matt, will you put up Jose's email address? Please send Jose an email address with your name, your shipping address, and what question you answered correctly, and we'll go ahead and get those out to you next week. All right.
Well, very good. So don't keep in mind this is as Sean mentioned earlier, a 5-part series. So we're going to get more into restores, replication, moving forward, and there will be a grand prize. I said it's a very cool Veeam backpack, laptop backpack that you'll be able to get there. So. And as Jose always says, I'm going to fill in a little bit here. Go to veeam.com, for more information. Of course, to download trials of all the Veeam solutions, and of course, go to the Veeam user forums to even get more information. There's a lot of we have developers out there, Veeam solution architects. They're very knowledgeable to answer any other questions you have. And of course, if not, just come to us. You can get through us through our emails aren't up there, but you can go through Jose. He'll get to us. No, but it's you can just do jason.leiva, so Leiva at veeam.com, or sean.liu, that's shawn.lieu at veeam.com. We're happy to answer anything you have.
Right.
Okay.
Absolutely. And I know we kind of went through the 2 different backup modes rather quickly during today's episode. Yeah. So if you have any further questions regarding that, you can feel free to email us, or if you have our user's guide, there is a section in there that details the 2 different backup modes. There's nice pictures, drawings, and diagrams to help illustrate what I was trying to illustrate on the whiteboard today.
And sometimes it even helps to have someone like ourselves actually look at your infrastructure. We're happy to do reverse WebExes or just talk about it and draw out what works best for you. So we can certainly do that. Okay?
Right. On that note, sorry for the technical difficulties today, but thank you for being patient and joining us for today's call. Remember, there's 3 more upcoming episodes where we're going to cover replication, we're going to cover UWare Technology, Sure Backup, the On-Demand Sandbox in episode 4, and then episode 5, we're going to talk about your different recovery options. Some of the questions, one of the questions that I remember were being asked today with the application-aware image processing, right? Backup of specific applications, block level restores or item level restores for those specific applications. That will be episode 5. So our next episode coming up next week, right, we're going to do them in succession here. Every week we're going to have an episode. So episode 3 is actually going to be covering our replication architecture. Tune in for that one. There's a lot to cover there. There's a lot of considerations, lots of best practices there to be aware of. So join us next week. Hope everyone has a great weekend. Thank you for joining us.
All right. Thanks, everybody.